Hello, everybody, and welcome to today's webcast on Goodbye AWS Lambda, Hello DBOS, featuring DBOS and our guests from TechMates Group, or TMG. Our agenda today is to introduce you quickly to DBOS. Then I'm going to turn things over to Thomas McNally, Head of Technology at TMG, and Aaron Brill, Engineering Lead at TMG. We're going to talk about their experience building TMG Fuse, which is an integration platform that connects Shopify and backend fulfillment systems on SAP. And they're going to talk about the development of that this year first on AWS Lambda, and then eventually switching over to DBOS, and explain why they did that, how they did that. The reason for the founding of DBOS, the founder's observation was that cloud development and even cloud application execution was broken, right? If you look at probably the most popular stack employed today, the cloud native stack, the problem that they found was that it was built on a 35-year-old operating system, Linux. And because Linux was not really built for today's volume of application and operating state data, it's not built to be distributed and fault tolerant like cloud native applications. It requires a whole bunch of layers in order to give it the properties of a cloud native application, right? So this very tall stack had too many moving parts, too many people to administer those parts, high hosting costs because they have to run somewhere, right? And large cyber attack surface area with all these different layers. So for people who've escaped some of that by moving to a serverless stack or platform as a service, which really frees you from the overhead of having to run and administer things like Kubernetes and containers and some of the security infrastructure. It simplifies deployment and development for you, but at scale with lots of Lambdas, right, or serverless functions or serverless code working together, it really becomes a spider web, which is hard to configure and secure and integrate. And if you have workflows that are executing those functions, things like statefulness, observability, durability, are still code it yourself, right? And in terms of the cost of serverless, it can become prohibitively expensive if your serverless code is accessing backend databases or very popular now, large language models, which can take quite a while to respond. The cost model for AWS Lambda is compute time, but that compute time includes the time that code spends waiting for responses from backend servers. So that cost can add up quickly. So they set out to fix that by inventing a new platform on which to run serverless applications in the cloud, the stateful serverless. And the big idea here was to create an execution platform that has a DBMS embedded within it. What that does is it makes state and all the things that depend on that, like durability, observability, high availability, all of those pretty much automatic, and they happen by default, which means you have to do a lot less coding. If you've done some development in AWS Lambda, you're probably familiar with AWS step functions, which is required, kind of an extra product and cost you have to employ to give your serverless applications that durability and crash proofness. And so it's really the ideal serverless platform for cloud applications that are accessing databases and remote services, large language models, and things like that.
So yeah, thanks, Andy. Glad to be here today and talk about our use case of how we've established success in the platform. When we do these types of stories, we like to just quickly give a context, just like you guys did with the origin story, about how TMG came to be. TMG stands for TechMates Group, and who we are is a full-service digital experience and engineering firm. What does that mean? Well, it means we help design, build, and implement solutions for organizations within the B2B and B2C realms. So we really focus on the commerce realm, but we also establish out into your fulfillment, your logistics, maybe it's manufacturing problems you have. And we kind of unravel all those difficulties that you have within your design, experience, strategy to help deliver some success for you. So we have a wide range of expertise within agile methodologies and how we establish the guardrails for your organization to help develop and produce features that are going to be driving revenue. And we also believe from a relationship standpoint, when we engage with our customers, that we like to do this in a person-to-person relationship. We're not just buying the implementation, you're buying the people to help deliver this. So our origin story started in 2014. We started with just a few founders. I've been with the company for about 9 of those 10 years, which is a lifetime in this industry. And we've grown from, I think when I joined, it was about 10 people to over 250 global employees. We kind of have established development centers within Latin America and Europe. And then in North America, we have a big base as well. And really from the beginning, our roots started within the SAP realm. That's the customer experience realm for commerce for big Fortune 500 B2B enterprise clients. And then along the way, we've established our roots within different ecosystems. And you can see some of those on the far right side within the Adobe realm. So you can imagine marketing technologies, content management, et cetera. Recently with Shopify, which is what we're going to talk about today. And you see some other partners there as well, like Viax for business process automation. And then as we entered the world of composable, which is the big buzzword over the last 5-6 years, we started to integrate some of those more granular partners to help establish those different places of function within your organization. So again, just the focus areas of what we do as a company, and I don't want to have a shameless plug here. It's really to give you an understanding of like how we operate and why we kind of developed in this way and the thought choices we made along the way. So our focus areas of how we deliver value for our customers is really that agile methodology of how we implement guardrails around development and iterate and introspect and develop value over time. We also focus on experience. So it's not just the development of like the actual underlying commerce engine. It's everything that you see front end visually. We also focus on strategy for businesses to help escalate their value. And then last but not least is the technology, which we're going to dive in today, which is we're developing IP, we're developing ways of working within your applications that you have in your organization to really drive success. So that's the company. And for who you're meeting with the TMG team today is myself, Thomas McNally, VP of Technology. Based in Montreal, I help manage our innovation, how we fit all the different puzzle pieces within your organization together to develop the right solution. My background is development through architecture and now solutioning. And then I have my colleague on the call, Aaron Brill, who will give the torch back to, who will go through a little bit of what we developed, why we developed it, and give a quick intro on himself.
Awesome. Thanks a lot, Thomas. Hey, everybody. My name is Aaron Brill. I'm the commerce engineering lead here at TMG and also our Shopify practice lead, here to help talk to you about TMG Fuse for Shopify. So what is TMG Fuse? So essentially, TMG Fuse, it's an integration platform specifically designed to bridge the gap between enterprise-level backend systems and Shopify, essentially making the connection incredibly simple and intuitive. It's built to handle the complexity of large enterprises while offering the ease of use that Shopify is known for. At TMG, we've always focused on serving large enterprises. And with that in mind, over the years, we've built a lot of the key integrations that come bundled with some of the big names that you may have heard in the commerce world, such as SAP, Commerce, and whatnot. And what this has essentially allowed us to do is to enable businesses to connect their intricate ERP backend systems into a digital commerce world, what we see today everywhere. And now what we've essentially done is taken that and brought that same level of expertise and experience, but into the Shopify world. And essentially why we did it was because over the years, we've observed a growing trend, which is more and more large enterprises, not just small businesses, are adopting Shopify as their e-commerce platform. And this shift essentially created a need where they needed to connect these same intricate, large, complex ERP systems into Shopify. And unfortunately, in the market, there wasn't a solution out there to do that. And one of the common things about a lot of our clients is that they had one thing in common, which is that they all integrate with SAP. So we kind of took the best of both worlds. We said, look, we've done the experiences of integrations. We've built the complex integrations in the past. How can we take what our experience of what we've done and bring them into the Shopify world? So when we did that, that's how TMG Fuse was born. But we said to change it up, let's take all those lessons learned and let's actually make it an app, a Shopify app that is designed for Shopify, where it's not a traditional, iPaaS integration platform as a service solution. It's actually a solution that's specifically designed and made to work with Shopify and all the different APIs and objects that exist in Shopify. And at the same time, connect it to a client's SAP instance and all of the different business objects and APIs inside of SAP. So essentially marrying both worlds, the ERP side and the commerce side together. And what we developed here essentially is an app that allows you to set up your integrations rather than through code, set them up as easy, manageable configurations. So more into how that works on the next slide. The way it works, it's really simple. You install the TMG Fuse app onto your Shopify store. What happens from there is you simply choose which SAP systems you want to connect to. Primarily, we have S/4HANA and ECC. These are the two big ERP systems in SAP. You simply just put your credentials, you establish a connection. Once you do that, when you want to set up an integration, let's say I want to send an order from Shopify to SAP. You go inside of the intuitive interface, you say, I want to connect to my SAP instance. Let's say it's ECC or S/4HANA. And you say, I want to use the create sales order function inside of SAP and can map a Shopify order to an order in SAP. Normally, what I just talked about probably would take months of integration. And in minutes, you can set that up right in TMG Fuse. And what does that mean at the end of the day for everybody is that all these big, complex organizations and businesses who are kind of stuck in that old age of commerce, they can go onto a modern, easy to use and intuitive commerce platform like Shopify in weeks without months. And this is huge. This is going to unlock a big potential for a lot of those big enterprise clients out there. And with the help of DBOS, we've been able to get there, which is fantastic. And once you set up your integrations inside of the TMG Fuse app, you basically can choose where you want them to be surfaced. So you can use them in the online store, you can use them across Shopify Flow, admin, and all the different touch points within Shopify. So not only are your integrations being set up as data-driven configurations, but they're easily usable across all areas of Shopify. So you have what you need, what systems to connect to, and the markets and the areas within Shopify to be able to release that information to, which is huge.
Awesome.
All right. Pass it back to Thomas. Talk about our journey at DBOS.
Thank you, Aaron. So that's kind of who we are, the app that we developed. Now, I guess the next logical step is how did we get there and how did we choose DBOS? So I think the motto that you see on the screen right now, focus on value creation, not managing infrastructure, is a theme that you'll definitely find throughout this. The first step of our entire journey when we approached this app was trying to figure out and model the design of the architecture, right? So you have your old monolith style of environments where you're doing everything in one application. It's a massive code base. You're deploying everything at once. You can run a 10-minute build time on your local machine. Those are the days, right? That's something we wanted to move away from. We wanted to be able to rapidly develop, rapidly deploy, and really avoid having to focus on infrastructure. And so the way that we approach that is kind of like what we heard, the serverless model. So we wanted to reap the theoretical benefits of a serverless model architecture, which is what you see on the screen today, right? It's scalability. If we are going to be handling customers in the commerce realm that have, well, it's timely, there's Black Friday coming up next month, who are having huge amounts of traffic and volume in that month in a given day. They're having thousands of orders per hour. Each of those orders takes seconds, if not sometimes minutes, depending on what type of ERP you're integrating to. That can hog your connections up, that can hog your infrastructure up. And so we want something that can horizontally scale on demand, that we don't have to manage to handle that traffic. And we also wanted something that could be fast time to market, right? We're trying to get into this realm with Shopify and integrations to the enterprise space. We know they're tackling that right now with tons of investment. So we want to be on the precipice of this. So we want to focus on core features not trying to modify our Terraform or our infrastructure as code templates, rather drive value, not daddle around in the infrastructure space. So the third thing is cost efficiency. When we're talking about serverless, we talk about scaling to zero. And what that means is when you're not using it, right, you can have those Lambda functions or those serverless functions not be running at that given time. And so you can reduce cost in that sense. Again, these are theoretical benefits. We'll go into a little bit more on this in a second. And then the last piece is resilience. We want to have these functions distributed across multiple zones so that if any certain data center was affected, which we see a lot of these days, we want to be able to make sure that our customers are handled safe and well, and that their transactions are going to go through still without reliance on any sort of outage like that. So what did that look like in the initial stages? This diagram is kind of what our approach was within the Amazon serverless space. That was kind of our partner that we had developed some applications on before. And so what we did is we designed what this would look like and actually went through an implementation on a vanilla AWS serverless architecture. And so I won't go through all the dialog boxes on the screen right now, but you're probably very familiar with this type of layout. Right now within our Shopify implementation and instance, they are hosted on the Google Cloud Platform. That's where our workflows and triggers of how customers will place orders and then how that's going to progress through the life cycle of the app start. So you can kind of read this left to right. Within the AWS cloud space, that's where we actually started to define all of these different services. And when I see this view, I like to kind of think of the anecdote of this kind of looks like a laundry list, or more aptly like a receipt from CVS of all the different services that you would actually garner from Amazon. And honestly, it's overwhelming once you start to go through their catalog of services. And from a very technical development standpoint, it's great because it allows you to have all that granularity, but you need a large team to be able to manage that and over time be able to maintain that. And so when we started getting into the development, we went through our first iterations of the app, we started to see like, yes, the benefits that we were just talking about are there in terms of like scaling to zero and how you can have resilience, but it comes out of the cost as you start to scale this out. And the maintenance and overwhelming burden of being able to manage all these different services, orchestrate them, monitor them, that's the work. It's no longer the development that you're seeing for the core features. And so we said, hey, this is great, this works, but one, it doesn't seem very cost efficient. And I'll be the first one to say, you can always refactor this to be a little bit more cost efficient, right? This isn't like the top end solution for how this could be, but we don't want to worry about that. And it's taking more time on the maintenance and management rather than development. So we started to look for other options. And what we were looking at is how can we ease the deployment development effort? How can we get more of these workflows? And it was mentioned earlier with the step functions in AWS. How do we maintain these workflows in a very simplistic way where we can develop them as code and we don't have to maintain them anywhere else? It's a little bit more manageable. And how do we ensure that all of the data that we're processing through our app, which is all going to be really commerce related, is having a reduced risk of data duplication, or if environments go down, how do we ensure that those transactions go through? How do we have a good, easy auditing trail for that? So those three check boxes were really where we found DBOS. So the first area of simplification of serverless development. I mean, you're pretty much able to deploy an app, which you'll see a little bit later, in just a few lines of code. You don't have to really manage an entire template of all these different services at once, infrastructure as code for many of you who know that. And you don't have to focus on managing these services over time. You can just focus on the features themselves, which is great for us. The workflows is kind of a DBOS concept that is like step functions, but I think one of the areas that we talked about just a second ago was that scaling to zero and the benefits or theoretical benefits of that. One thing to note when you're talking about serverless functions and architecture is there's more than just those serverless functions as part of that. So in that diagram I showed, there's a lot of different pieces to that puzzle that make up the architecture, and those don't go to zero. So you're going to be taking the cost of all of those things like your DNS, your load balancer, how you're routing this, those add up and the costs just start to mount up. Now, we were in the development stage at this point, so the costs weren't too great, right? Because we didn't have any customers on at the time. but we are a service company. And the reason why I wanted to explain at the beginning is we kind of do our business with how we consult and implement on customers. We don't develop products as our main line of business. So we didn't want this to be something that was going to be an overbearing cost. And the last piece here about data integrity, I think DBOS's motto around transactions is really flowing through the entire methodology of making sure you can process end to end, how it traverses through your workflows, how it actually captures into the database. And I'll talk a little bit more later about how they actually capture this data so you can audit it. But these are the three main drivers to why we chose DBOS. So we then revised our architecture and did a refactoring to a little bit of a simpler format. I know there's a lot of lines here in terms of the flows, but if you really look at the main points of applications within the architecture, it's a much more simplified flow. We still have Shopify and Google Cloud on your far left. We have another partner in the mix here called Gadget, who helps power some of our front-end visual and integrations to Shopify for a more out-of-the-box view. But really the meat and potatoes, so to speak, of all of the logic for how our business transactions execute is done in DBOS, which you see here. And they help manage all of the underlying AWS logos or blocks that you saw earlier from that CVS receipt. And you don't have to worry about any of it. And so the big value here when we made that refactoring is we were able to do this very quickly, and we were able to avoid having to maintain any of that underlying infrastructure and focus on the value. So what you'll see in that DBOS architecture is some of the pieces that Aaron was talking about earlier about how we have a file feed connector, which is a way to transition files from different systems and how to consume them and how to dynamically map to them. We have an SAP connector as well, which is really focusing on the ERP side of the business. So if you're an enterprise, you have this ERP up and running, DBOS will handle the connections to it, map the data, process it, and send it back to Shopify. And all of these different workflows have transactions which are persisted in that Postgres DB, which is super performant, and we don't have to worry about maintaining any of it to optimize it. It's done all out of the box. So that's the simplistic view of what we are in now with DBOS. It's way easier to maintain, and we've kind of relieved ourselves of just focusing 80% of the dev effort to maintain these services. So that moved from AWS Lambda to DBOS was very fast, actually. And I think this is one of the selling points of fast time to market. What took us weeks, if not months, to actually develop that in AWS from scratch. And I'll say this with a preface, maybe you have some templates that you have from other existing apps, and you can get this up and running quicker. We were starting greenfield in terms of like how to structure all of these services together. So it took a long time. But when we went over to DBOS, I mean, this took just a few days to do that migration, to get those first initial connectors up and running. Some of the things that helped us along the way, and we have a few bullet points here. One, spending time to understand like the DBOS specific paradigms, so communicators, transactions, workflows. They got great documentation to go through and learn about this along the way. The earlier that you do this, the easier it's going to be to design out your paradigms within your design patterns. We were able to actually replicate all the different API gateway routes we had for all the different connector workflows, like how you would actually submit a request to your app, very simply in the code itself with decorators. So I think Steve Ballmer once said it in a Microsoft conference, developers. Here, I would say decorators. Those are your friends within the development lifecycle. Then we looked at how to actually eliminate our complex connections and identity management with DBOS decorators as well. So the security auditing you saw in a few slides ago from Andy, that's something that was way easier within this paradigm. We also were able to transition from step functions, which is the AWS paradigm, to workflows very smoothly, just because the paradigms are very similar. So we were able to copy over that logic very quickly. The fourth point here, some common pitfalls you have when you're doing development is being able to monitor and debug, right? Sometimes you never know what service your transaction has gone through. It may progress through multiple different Lambdas. DBOS does an excellent job of tagging those transactions and seeing the whole way through so that you can actually view exactly what has changed and when it's changed. They have a feature called Time Traveler, which is super useful, that you can actually see the state of a given database value within time, and you can kind of step through it to understand how it's been manipulated over time. This helped us tremendously to identify problems and fix them. And then the last thing, allowing us to unify our stack around TypeScript. So you can customize DBOS in many different ways, Python, TypeScript. The fact that we are able to unify our language that we develop on is something you should look at, right? I mean, development is development. You'll learn it. You'll be able to do the, Java, Rust, whatever. But the idea is look at your development team, look at the resources that you have, what skill sets they have. And if that's something that sticks around with Python or TypeScript, start to leverage the strengths and synergies around that so you can develop quicker. So we've been on that infrastructure for about 5 months now, and we realized a lot of benefits to this. Some of the key highlights that we've seen so far is hosting costs. So what I said earlier about scaling to zero, that doesn't apply to your whole infrastructure. And actually the transactions that we've been running through here with customer data, we've achieved almost a 15 times less than previous AWS costs. So we're starting to see a huge smush in terms of our pricing that we have to host and maintain for our customers, which is great and something that you should look at. There's a few articles from DBOS that explain some of the nuances of why that is and how that's managed. Faster feature development, again, build in days, not weeks. You don't have a complex release cycle that you typically see in enterprise environments where you need to develop, test, go through the QA, the stage, integration environments, production. This is something that has been much easier with this paradigm. One thing to note as well for all the developers is you have a much closer alignment between your local and production environments than you do in other applications and frameworks. So that's a huge selling point, because how many times do you go, yeah, it worked in the QA environment, then you push the prod and it broke because of underlying data issues. That doesn't really happen here, right? Just because of the nature of how it's architected and the simplistic nature of the infrastructure. So you don't have to worry about some configs that you didn't have configured in your prod environment versus lower. Everything's kind of similar and the same. So it makes it a lot simpler. Debugging, we talked about time traveler mode. That's big. Everything is also managed through Grafana, how you can transact and look at these throughout time. So it gives you a much better reporting structure to view. And then the last piece, simplified deployments. This is a big, huge win. So when we're provisioning new customers on the platform, being able to provision our app without having to run through all these Terraform deployments and trying to make sure that all the configurations are matched up for each new customer that comes on board, our onboarding process has been minimized substantially. And so we really only need that for some ancillary services that we still maintain in AWS for security reasons, that the customer may want to have their own instance. But for everything else, it's been smooth sailing. All right. I will stop there and hand it over to Aaron and James.
Awesome. James also, we didn't get to intro yet. James is also one of our senior engineers here, has helped, been absolutely instrumental in developing TMG Fuse. And we're really excited to show it to you. So James is sharing his screen right now, and let's get to it.
Yeah, hey everyone. So yeah, this is what TMG Fuse looks like in the Shopify admin. It's our app. So I'm just gonna, in the interest of time, just kind of dive right in and take a look at our connectors. Like we've said a few times now, we have a file feed connector, an S/4HANA connector, and an ECC connector. I've already set some stuff up for the demo, so we can take a look real quickly at like the file feed connector. We can see this is our product file CSV file feed integration, and basically we're taking a CSV that we've put up in S3, and we're consuming that and we're mapping it using this linked mapping here. Once that file's been uploaded, and I've already done this, we end up with these two products here. But now for the really cool part is the ERP integration. So we've got,
and sorry, before we get into that. So like the goal of that file feed connector is a lot of times SAP and other ERPs, they love to do data extracts where they'll just take like a big data extract of like, let's say products, customers, whatever it might be. And that's how businesses work, enterprises work, where we need to bring that data into the commerce platform. So like rather than developing a whole integration that can handle this file feed connector essentially allows businesses to continue to go in their paradigms where they generate these large spreadsheets, which can be like, hundreds of thousands of lines. And we can just essentially map that data directly into Shopify all inside of this interface without having to manually develop the integration itself, which is a huge game changer. So if like, let's say in the future, somebody from the business side says, oh, you know what, we got to add this extra attribute to the customers. So we're going to be sending you guys a delta of the, the difference of, what's changed in that and the customer file feed or something like that. Then that can just seamlessly come into here. So you would just go inside Fuse. You'd say, oh, I want to update this mapping and take in this extra attribute and map it to something in Shopify so that Shopify can have that data now there. Ordinarily, when you have to make a change like that, you'd have to immediately crack out the keyboard, get developers involved, make sure it gets, tested and deployed and push through a release cycle. And so by the time you make that like 1 or 2 liner change, let's say, assuming it's that small of a change, then you're talking even like a week probably till that's released. Whereas if you use Fuse, you can set up changes like that super fast right in the app. So back to James.
All right, yeah, and then so with the S/4HANA connector, similar concept here, except we're not connecting to S3, we're connecting to an SAP S/4HANA appliance. And you can see we've got a few integrations here built out. We've got an order proxy integration, which is for proxying the orders. We've got a credit check proxy integration for checking a customer's credit. And then we've got a specifically create S/4HANA order integration, which that's what I'm going to kind of walk through right now. I have it here, but I'll walk through what building that actually looks like in our app. And you can see like these response times are really fast. This is all DBOS. So let's say create S/4HANA order again. We've got our connection. This is the connection. I'll bounce back out and we can look at what that looks like as well. We're sending data out from Shopify. This service name, if you're not familiar with SAP, this is just what they look like. But this is, we're going to use the API sales order service, and we're going to be mapping an order to a sales order, and we're going to use the create function, and we're going to create a new mapping. And we're going to name this, new order mapping. And we can hit this add mapping entry, or I can just hit the easy button, which pre-populates all of our values. And you can see we've got a whole bunch of data here. We've got our standard sales order type. That's what this OR stands for. And this is mapped as a static value. We also have down further, we've got our non-static values that are actually being pulled from some of the Shopify data. This is all information that we don't really have access to in Shopify. Like we could create mappings, we could create data structures that allow us to have it, but we just don't. So we're just kind of pushing it in there through a static value where we do have things like current total price for that order that we can map to the total net amount. Those are pretty much one-to-one relationship. We also have the ability to use these transformers. And what a transformer does, basically, you can see we've only got a limited set right now. But basically, we're taking something from one format. In Shopify, they're storing the date as just a number, but in SAP, it's required to be in moment, like as a moment instance. So we just have a transformer that does that for us. And we can create those very, very quickly. And those are just, again, living in DBOS. So this list is dynamically generated based on what DBOS has access to at the time. So I'm not going to hit save because we already have this, but I'll go back and I'll just copy this. We've got this fun little button here. And then, to just look at what we're actually doing, like, if you're familiar with SAP, with S/4HANA, these connection details, really anything, the connection URL, a username, and a password, and that's all we really need to connect you. So then a little bit about the internals of how some of these things work. I'm going to pop into this entity relationships, and we'll take a look at our products. So you can see we've got 2 products, and these are not the same 2 products that we saw over here. These are the products that are stored in DBOS. We store a version of everything in our system so that we can link all of the different systems that are connected here. You can see we've got 4 different connectors. So if we take a look at the Shopify connector, we'll see now those are linked to those same 2 products. The titles match because of course they do. But basically we're saying this product in Shopify maps to this product in DBOS. And then if I go to the S/4HANA connector and I say, I want to look at what are these mapped to for this BPI NST SAP connection that we were just looking at. And you can see here, now we've got material numbers from SAP that we're also linking those to. So when we create an order in Shopify, which I'm about to do, with one of these products, it's going to be able to map those products from the Shopify representation to the SAP representation, create the line item, create the order. So let me actually just run through that real quick. Right, so I'm going to search for a product, and I'm going to use our red XL cotton t-shirt, and we're giving this one to Aaron.
I'm a big spender here.
Yeah. And yeah, we're going to create that order. Oh, I didn't actually set up the flow. So we'll do this again in a second. We use Shopify's flow as a workflow engine. So let me just quickly set this up. And TMG Fuse, create S/4HANA order. And there. And then we're turning that on. Okay. So now I'll go back and I'll create another order. Same thing, we'll do it for Aaron again. All right. So now if we go back to flow and we take a look at that new workflow, you can see it was just run now. It's just completed now as well. DBOS is really, really fast. And then if I take a look at this and I refresh our dashboard, and this is the back end. I've made it extra noisy for the demo. You can see it's very, very noisy, but these are all the steps. So if you're used to like a step function, if you're used to kind of having your Lambdas organized in a step function, you know, this is the output. This is each of the steps of our workflow. This is the output of each one. And you can see like it's taking an order, it's transforming the order, and then finally we're getting an SAP order. So now if I come back here to SAP, and I search for that ID that I just got, here's our order, here's our TG11 material, like I showed in the entity relationships view. So it's taken that order from Shopify, it's transformed it into what SAP requires. You know, it's created the corresponding line item for the correct product. And all of that happened in like a second, probably less, once it actually hit DBOS. So yeah, that's DBOS has been extremely quick for us, and it's been great because these workflows need to be fast for our customers.
Oh yeah.
But yeah, so I'm gonna stop there and hand it back to Aaron.
All right, James, thanks for the awesome demo and overview. Appreciate it. And I'm gonna play hot potato and hand it over to Thomas if he has anything to add there.
All good. I think Alex from the DBOS side, we can pass the torch.
That's so great, guys. Great working with you and great to see your app in action. I'll start sharing screen though. I'm not sure if you guys are kind of a tough act to follow, you know, but I figured I'd show a quick getting started with Python, even though you guys use TypeScript for your workflow. I figured why not mix it up and show our Python connection just in case someone in the audience is Python inclined. And we'll just do a couple of things, right? So the theme today is connecting systems, right? Connecting complicated APIs. So can we have a very simple hello workflow that does two things? Call a third-party API and inserts a record into our Postgres table. And it's not really about those two steps specifically, it's about executing those two steps reliably. So we'll start with a regular Python app without DBOS reliability. And then I'll just add 4 lines of code to make the thing reliable. And then I'll deploy it to the cloud. And I'll try to do all of this in about 5-10 minutes. So let's see how that goes. By the way, I love the CVS receipt metaphor. It's cool that it also works in Montreal. I didn't know that in Montreal.
It's global.
Okay, so here I have just set up a Python 3 virtual environment, right, on this Mac. People always ask me, can I run DBOS on my laptop for testing? The answer is yes, right? So we set up a virtual environment for Python, and we say pip install DBOS, okay? So DBOS is just like a package in pip, and we can install it into our little directory. And now I'll say DBOS init. So now what this does is I have this directory called my app, and in it I will create a DBOS project, also called my app. And this populates this directory with all the things I need to run a very simple DBOS app, right, in Python. The main entry point for the app is going to be under my app/main.py. Now this comes populated with a welcome to DBOS app, and we're going to promptly delete all of this because I have a piece of code in mind. Okay, so I'll say paste this in here. And let me just walk you through what this code does. Like I mentioned in my slide, we have 2 things, and we have some things here that are commented out. So don't pay attention to these yet. Ignore them. They'll come in handy later. So the first thing we do is we call a third-party API, and we use something called Guestbook, which is a little app that we have just for this purpose. It's live in DBOS Cloud. So we call this API, and then we make a record into our database saying that we've called the API. And we serve up an endpoint on /greeting/name using Python fast API. And so when the send point is hit, we first sign the guest book. So call the API and then insert greeting into the database, right? So replace these 2 steps with whatever you're working on. It could be call an LLM model and then call another LLM model, or it could be add a record to SAP like you guys were shown, right? I'm just showing these 2 simple steps because I want to focus on executing both of them reliably. So let's run this app. I have my terminal here. And what I need to do is I need to set up Postgres locally. So luckily we have a handy Postgres container that we ship. So as long as you have Docker, you can say something like Python 3 start Postgres Docker. That script comes with our DBOS init. And now I have a little Postgres database running in my container. It's just a test database for this app. And now I can say DBOS migrate. So the migrate command creates the tables that my app needs. And finally, I say DBOS start. It reads the things and it starts running a server on localhost on port 8000. So I just started an app on my laptop from scratch. Let's try to hit this app. So I'll say curl this address, and remember we're serving an endpoint on greeting, and we'll say TMG. Okay, so we go into the app, we say step 1 is executing, and then step 2 executes. We run the we assign the guestbook API, we record an entry into the database, and it returns saying that it should return with a message as well here. Okay. Yes, there you go. It says, thank you for being awesome, TMG. This is what I wanted you guys to see. Okay. Now, the problem with this app right now is that it's not reliable. This workflow is not executed durably. And in fact, it's not a DBOS app yet. Okay, it's running as a it's not even using any of the DBOS capability. It's a regular fast API that uses SQL Alchemy to talk to Postgres, right? And the problem is that if I run this curl command and I crash the app in the middle, I get step 1 without step 2, right? So I have step 1 where we signed our guestbook API, but we did not create a record in the database, right? And so this is the kind of problem that you could run into in production when you're processing a transaction. Or let's say you add a record for your customer to database 1, but not to database 2, right? And now you have inconsistent data. And if it's commercial data, it could be expensive. And loss of consistency could lead to a loss of revenue, right? So let's fix it. So now what I'll do is I'll go back to those pieces of code that were commented out and I'll uncomment them. So first, at the beginning of the app, we initialize DBOS with the fast API. Then we go to our signed guestbook step and we decorate that as at DBOS step. As Thomas said, decorators, decorators, decorators. So all I'm doing is adding these decorators. Insert greeting is going to be another step. And now DBOS workflow is going to be another step. Okay, and that's all I need to do. So let's try this again. So in the bottom terminal here, I'll restart the app, change the file, saved it. And now I'll say, execute the API endpoint again, and I'll crash the app. So now, again, so far, we ran step 1, we stopped the app, and now we're in this inconsistent state. Now watch what happens when I restart the app. Okay? So when the app comes back, it knows that it was in the middle of a workflow, and it recovers the workflow. All right? So just by adding those 4 decorators, a lot of database things happen under the hood to make the execution reliable. And now we are guaranteed that even in the event of a crash, as long as we restart the app, it will continue executing from where it left off. So again, we did step 1 back here, then we crashed it, then we restarted it, and now we have step 1 is not re-executed, and step 2 is executed properly. Okay? So now that this app is reliable, I can deploy it to the cloud. And I do it by saying DBOS cloud app deploy. And it asks me to log in. The first time you do this, it will ask you to create an account. By all means, do that. Okay. Okay. So this is the app saying that it needs a requirement TXT file. This is how you know the demo is live. So I need to run this command. I need to say pip freeze and pipe that into requirements.txt. And then I'll say DBOS cloud app deploy again. And a few of our engineers are really, really into making sure that this deploy time is as quick as possible. So we got it down to like less than a minute on Python. This uploads all the code, provisions virtual machines, provisions the URL for you. And so now I have this app live. So instead of curling something local, I can curl this endpoint online. It's a publicly facing URL now. And it should, because it waits for 5 seconds, that's what the app does, right? And it gives me the response. And now I can say, go into console.dbos.dev. You see, I have a few apps. This is the app I just deployed. And I can look at the workflow I just ran. I can look at the logs here. And I have the dashboard as well, the same kind of dashboard that Thomas showed. I have a few apps running, of course, and so I can even select data specifically for this app. We can see the traces we ran. and we only used 71 CPU milliseconds. So that's a tiny amount of CPU time, and we only bill users for actual CPU milliseconds used, right? So here you can monitor exactly how much usage there is as you go. So there it is. I think it's been right about 10 minutes, and we went from zero to a reliable cloud app. So I hope that was interesting and useful. And let's see what questions you guys have.
Thank you, Alex. Yeah, we have a few questions, and we're actually running out of time. We only have a few minutes, so we're going to get to as many as we can. I think this is for you, Alex. The person wanted to know how audits are done with DBOS. Can it handle crypto? So maybe you can talk a little bit about the crypto use cases we've.
Yeah, we are talking to a couple of interested users in the crypto space. So back in the theme of connecting complex systems, some of the users we're talking to, they want to do things like handle on-chain events off-chain, right? So something happens on-chain and a DBOS app monitors it and responds off-chain. Or in one case, somebody was building a game where there's an on-chain component to the game where things happen on the chain, and then there's an off-chain marketplace with a traditional database like Postgres. So again, just like I showed here, I was able to entangle, let's say, or connect an API call to a database, right? In the same way, we can connect on-chain events to off-chain events reliably, right? And so that's a very interesting use case that we're working on with a couple of clients. So we'll be very interested to talk to you more about what you have in mind. Audits, as far as, because we put everything in the database for reliability, and when I deployed my app, I showed you my workflows. That was a database query to a database that has all my data, right? There's retention policies as far as how long to keep this data and so on. But basically everything goes into a database and it's queryable, right? So we can go back and look at your history of execution and see exactly what happened at any given point. And that's exactly what our time travel component does, as Thomas mentioned.
Thank you. Question, I think for, I'll just pose this to TMG people. You guys can decide who to chime in. But the question was the code easy to move from the code you'd written to run on Lambda? Was that easy to move over to DBOS? And maybe the same goes for the step functions.
Yeah, I can jump in there. Yeah, it was remarkably easy. We had a Python code base in Lambda because that was what we had chosen to do there, and then moved to TypeScript with DBOS. So there was no one-to-one portability really, but because the concepts of like a transaction or a communicator and a workflow are so analogous to a Lambda and a Lambda and a step function. It was really easy to take what we had already modeled to kind of look at each of those discrete actions that were happening in our step functions and then kind of combine them into a workflow. Yeah, I mean, we took the file feed connector and I think it took us 2 days to convert it, like the whole thing, including figuring out like how to use different AWS SDKs and like all of the stuff that comes with a language change is included in those 2 days. It was really fast. It has been really fast.
Well, thanks. Here's another question. It's a three-parter. I'm going to take one part, and these questions about comparing DBOS and Lambda. Part two is DBOS cheaper than Lambda? We have some benchmarks on the website that show that the answer to that is generally yes. It's your mileage will vary, but for two big reasons. Number one, I think as I mentioned at the beginning of this, when you pay for compute time in both DBOS and Lambda, but Lambda includes the time your code spends waiting for a response from a backend database or backend service as compute time, and we do not. So that can cut your your compute time billing by double or even orders of magnitude in some cases. The other cost savings is if you're doing durable workflows like Thomas described, using step functions in AWS to make that easy and possible is an extra cost. DBOS includes durable workflow executions, just a regular feature at no extra cost. So based on that, you'll see quite a big cost savings with DBOS. The other two parts of this question have to do with, I think, database performance. They're wondering how many queries can an application execute, and is DBOS beneficial in all scenarios? Is a high workload with 1 million queries?
Yeah, I can take that, Andy.
Yeah. So I think it's a question about bring your own database. So that
Yeah, exactly. Basically, DBOS is great at pushing the workload to your database, right? So we run with Postgres or Postgres compatible database. I see another question about OpenShift. So as long as you have Python or TypeScript and Postgres, you can run DBOS, okay? And DBOS is great at pushing most of the work into your Postgres or Postgres compatible database. And you can connect your own Postgres database to the cloud. So the size of the server will dictate your performance, right? We run the apps in these little Firecracker VMs where it's very easy to scale them up and launch more when you have high load. But your database is going to be where most of the work is. And so you can just run a larger Postgres server to handle more load. Or use one of the newer sort of Postgres compatible solutions for that use case.
All right, great. I think we're beyond the top of the hour, so I'm sorry we couldn't get to all the questions. We'll get to the others we'll follow up with you in email. But for next steps, we invite you to come to dbos.dev and explore DBOS more deeply, create a free DBOS cloud account, or use DBOS Transact, open source DBOS Transact to start decorating your code and make it crash proof with exactly once processing. And again, if you're looking to integrate e-commerce front ends with back-end fulfillment systems, Shopify and SAP, for example, we invite you to visit TMG and check out TMG Fuse. All right. So on behalf of Alex and our pals at TMG, want to thank everybody for tuning in today and look forward to seeing you on a webinar in the future. Thanks very much.